As we lose cells, we can start losing dexterity. As we lose the ability of the cables within the cord to conduct signals, we start to notice changes in our ability to manipulate our hands, to navigate when we walk, and to do fine motor skills. This is new. This is exciting stuff, and this is a very, very different way of looking at the spinal cord. So what this is what's called a diffusion MRI, and this is a standard MRI. And what this is looking at is, here's the brain, and again the spinal cord, and this picture, the spinal cord looks like a gray tube. You can't see the nerves, you can't see how many nerves there are, you can't see if there's any damage to the nerves. You can just see the spinal cord, kind of a shadow of it. This is diffusion imaging, and what this shows, this structure here is this. And what it shows is all of these fibers. These are actually the nerves. This shows us a healthy spinal cord. So what we're looking at here is a very wide open spinal canal, the spinal nerves traveling through, and what it looks like when they're normal. This is an end-on view. And when we look at the nerves, a normal spinal cord is going to be completely red. That shows that all the water, all the tubes, all the hoses are flowing water in the same direction. So this is an example of a normal spinal cord, and this is what a spinal cord looks like when it's damaged. So this is somebody that we can actually look into their cord and say, hey, you've got some stenosis, but your cord is pretty healthy, versus you're starting to get into trouble. You can quantitatively know, are you starting to get to the point where this might be dangerous? This is the patient that was a little bit confusing, where there's a lot of symptoms, but there isn't severe pressure. But if we look at the actual nerves themselves, what we can see is severe damage. The cord, instead of being nice, healthy, is frayed. It's called anisotropy, and that shows that the spinal nerves, instead of the fluid flowing in one direction, is leaking out, kind of like if you run over your hose too many times in the driveway. This is an ultrasonic tool. It uses vibration. It's more powerful than the cutting tool. It'll go through plastic and bone a lot faster than the traditional tool, but because it's not sharp and because it doesn't spin, it's very safe around delicate structures. You can barely pop the balloon if you try to with this. So this can be used in direct contact with nerves. You can actually physically touch a nerve with this tool if you know how to do it. It's not simple to use. And you can work in very, very small incisions.
Plenty of visibility front and back.
Oh! This is where I wasn't
You are okay? You speak Portuguese? No? English? You feel pain?